Welcome to Calculus by Ansari. In today's video, we're going to discuss limits. And first, we're going to discuss what the fancy notation that looks like this. Limit as x arrow and then some number here. I'm just going to say a of some function that they write here means. And then we're going to discuss how we can evaluate limits. So first, let's define a function f of x. And we'll define it to be, x squared. Alright, let's graph this function first. So we have our regular y-axis and our x-axis. So label this x, label this y. And we know that this is a parabola, and if you don't know that, you can just plug in a few points and see how the function is reacting. And you'll notice that it's just some sort of parabola that looks something like this. So let me draw this out. Oops. Okay. Something like that. So what we can do to this function is we can evaluate this function at certain points. We can say, what is the value of this function at, 3? Well, at x equals 3, we want to know what y is, or f of x, same thing. So f of 3 is 3 squared, which is 9. So this point right here should be 3, 9. Okay, well, let's evaluate at some more points. Let's evaluate this function at x equals 8. Alright, so x equals 8, we can plug in 8, we get f of 8, and that becomes 8 squared, which is 64. So here, let me just extend this a little bit. We're going to pretend like x equals 8 is right here. And then this corresponds to some value, let's just pretend like it's right here, which is 8, 6. It'll probably be a little more this way, but I'm going to run out of space. So let's just say this is 8, 64. Now, let's say we see this fancy notation of a limit, and it says the question says the limit as x goes to infinity, this is how you read this, limit as x goes to infinity of f of x. Now f of x we defined here to be x squared, so we're just going to use x squared. So I can just rewrite, I'm gonna go right here, I'm going to rewrite it as the limit as x goes to infinity of x squared. Again, this is how you read it if this is the first time you're hearing that. It goes the limit as x goes to infinity of x squared. And what this simply means is what happens to the function, or when one says to the function, they mean to the y value of the function. What happens to the function when x approaches infinity? Now, the reason why we use limits for this is we can't quite plug in infinity. It doesn't really make sense to say f of infinity. I mean, I guess you can just arbitrarily plug it in and say it's infinity squared, which, this is not very mathematical right here. And for that reason, we use limits. We say the limit as x goes to infinity of x squared. Well, the answer in this case would be infinity. And the reason for that is we're just seeing what happens to the function. Again, when I say to the function, all I mean is what happens to the y-coordinate of this f of x as x does something. And in this case, the something is as x goes to infinity. So as x approaches infinity, as we plug in bigger and bigger numbers, and we go this way, it's clear that the y approaches infinity as well. So what we can say is that the limit as x goes to infinity of x squared is infinity. Okay, so that should be pretty intuitive. Now, let's discuss one more limit for this function. In the next video, we're going to talk about why we even use this. I discussed it a little bit in this video, but I'll discuss more on why we use this notation. And it has to do with something called discontinuity. So if you know what that is, that might be a good hint. But if you don't, we'll discuss it next video. But let's do one more limit. So let's say we want to figure out what the limit as x goes to 0 of the same function is. So limit as x goes to 0 of x squared. Well, we want to analyze what happens to the function as it approaches 0. And again, what that means is what happens to the y-coordinate of this function as x approaches 0. Well, this function is very clear on what happens as x approaches 0. The y approaches 0 as well. So this one's pretty clear as well. So limit as x goes to 0 of x squared, well, that's just 0. And this one, we don't really need to even use limit notation. We can just say, we already know what happens as x goes to 0. We can just plug it in. We can say f of 0 is 0. So this is actually this is the same thing in this case, because we're not using we're not using weird notations such as f of infinity. We can actually plug in f of 0. So this is okay. But we can also define it with the limit. We can say the limit as x goes to 0 of x squared is equal to 0. Okay, next video we're going to discuss on why we use limits more in detail. So talk to you then.